Today we are talking about the pair sample t-test. Last week we talked about the independent sample t-test. So today's topic is another type of t-test, specifically when you're trying to measure people over time. You're trying to see whether people change from this week to next week, or from this month to next month, or whether they change from before treatment to after treatment. Really is a really helpful test to learn. All right, so we'll talk about. I gotta update this actually. This is the sample t-test, and we'll go over the similar structure, why we need it, what is it, when is it used, and how do you compute it. Why do we need it? A lot of research investigates the questions about how people change over time. And this is called longitudinal research. It just means that people measure at multiple time points. And we use the pair sample t-test to answer these type of longitudinal questions. So examples of these questions could be, do students experience an increase in the GPA from before to after attending a study skills workshop? Do patients experience decreased pain from before to after using a pain patch treatment? Do people in New York experience more PTSD symptoms after the 9/11 attack compared to before the attack? Like you can see, it can answer both questions about treatment and intervention, and about naturally occurring events like 9/11 or whatever event that's happening in the person's life that doesn't require intervention from a researcher. So what is it? So the pair sample t-test is used with research designs that measure people over two time points specifically. And so we call these type of designs either repeated measures design or within subjects design. They both mean the same thing. Repeated measures meaning, that's that one I like is self-explanatory because you're repeating the number of measures the time that you measure the same participants over time. Within subject design just means that you're measuring people, the same people across time. So you're not measuring different people. You're not measuring two groups of people. When you're measuring two groups of people, that's called a between subjects design, because you're measuring between two sets of subjects, two different groups of subjects. When it's a longitudinal design, it's called within subjects because you're measuring one set of subjects. As far as the definition of repeated measures or within subject, it is one in which the dependent variable is measured two or more times for each individual in a single sample. So that's important to note that we're looking at a single sample, a single group of people over time. So we're not looking at two or multiple groups. And we're looking at the same participants at each time point. So we're asking the same participants survey questions at multiple time points. So if we have 100 participants that we asked about depression at time 1, then we would ask the same 100 participants at time 2 about their depression levels. Okay. What's important to know about the pair sample t-test is that it uses different scores. So basically, it's the difference between the X values at time 2 versus time 1. And we use that in the analysis. This is different from the independent sample t-test that we learned at the last lecture, because that uses X scores in the analysis. But with the pair sample t-test, you use different scores in the analysis. And this will become more clear when we get to the computation section. Okay, this is a slide from previous lecture. It just talks about the 3 different types of t-tests. The one sample t-test, which is to compare the mean of a group against the mean of a population. The pair sample t-test, which is what we're focusing on today. And then the independent sample t-test, which is what we focused on last time. Remember, the independent sample t-test is when you're comparing 2 different groups on the variable of interest on the dependent variable. The dependent variable is just another way of saying what's the variable of interest or the key variable that you're looking at here that you're trying to compare for the differences. Okay. I think I mentioned last lecture that we will only be looking at the independent sample t-test for this class, but then I remember recalling in the syllabus that we had 2 weeks set aside for t-test. So I thought that was perfect. That way we get to look at the other very popular type of t-test, which is the paired sample t-test. This is the formula, and we'll expand on this formula in just a minute. Okay, so let's do some compare and contrast between the independent sample t-test and the paired sample t-test. Independent sample t-test, what we learned last week, is on the left side of this table, whereas the paired sample t-test is on the right side. So you see here on the first row, first row, the purpose of the independent sample t-test is to answer questions about group differences. For example, do men and women differ in the average height or weight, for example. Whereas the purpose of the paired sample t-test is to answer questions about change over time. So before, when you measure people multiple time points. The independent sample t-test tests for differences between two groups on a key variable, whereas the paired sample t-test tests between two time points for a single group on a key variable. That means that the independent sample t-test has two groups that you're looking at, whereas the paired sample t-test only has one group that you're looking at. In the independent sample t-test, people are surveyed at one time, whereas the paired sample t-test, people are surveyed at two different times. Okay, so just to reiterate, when do you use the paired sample t-test? Use it when you're measuring change over time. And what's important to note about the paired sample t-test is it can only measure differences between two time points. So before, after treatment or intervention, or pre or post. Right, so last week we learned about hypothesis testing. We learned about hypothesis testing for conducting an independent sample t-test. But this week we're going to apply the same framework to learn about hypothesis testing for paired sample t-test. So we have the same 4 steps here. The first step is to state the hypotheses. Remember, there's always 2 hypotheses. First is a null hypothesis, or H0, H naught. And how you read this is mu sub T1 minus mu sub T2 equals 0, or mu sub D equals 0. And that just means mu is just the mean in the population. The mean of the population at time 1 minus the mean of the population at time 2 equals 0. That means there's no difference in the scores between time 1 and time 2. That means people don't change from time 1 to time 2. And the mu sub D equals 0, that just means mu sub D is just another way of writing mu. The mean for the D stands for difference between time 2 and time 1. So difference in the mean from time 2 to time 1. So in words, the null hypothesis states that for the population, there's no significant difference between the groups. It shouldn't say groups, it should say time points between the time points. For the population, there's no significance between the. Okay. Right. So null hypothesis is there's no significant difference between the 2 time points. The alternative hypothesis, this is what we're using, what we're testing, what we usually want to find when we're doing research. This says that for the population, there is a significant difference between the 2 time points. And again, the way you read the Greek here is mu sub T1 minus mu sub T2 does not equal 0. And the way you think about that is that the mean in the population for time 2 minus the mean population for time 1 does not equal 0. That means there is some type of change between the two time points. So after you state the hypothesis, then you have to compute the test statistics. In this case, it's not the independent sample t-test. Here's the t-test. And for our class, we'll be using the Google Sheets for software for this. And again, we'll be using the Excel minor analysis toolpath for this. This is the same tool that we used last time for the independent sample t-test. And you see here, there's instructions on how to install this Excel minor analysis toolpath. And there's instructions how to use it too. And so I won't read through the instructions on how to use it because we'll go over the demonstration in the practice exercise. Also important to note that there are some statistics that are not computed by the Excel Miner tool pack, so we have to compute those ourselves manually. And some of those things are like the different scores, the variance of the different scores, the effect size, like the Cohen's d effect size, the variance explained effect size. And so we'll go over how to compute those as well. Right. So after step 2, when we compute the test statistics, step 3 is we make a decision. This is where we look at the p-value. Step 2 gives us the p-value. Step 3, we have to decide whether whether there's a significant finding or not. Remember p-value is the significant, is what determines the significance. If the p-value is less than 0.05, then there is a significant difference. There's a significant finding. There's a significant difference between two time points. So that's good. That's what you want. If p is greater than 0.05, then there's no significant difference between the two time points. Hence this base. And the way you write the results in APA format, APA standing for the American Psychological Association, it's very similar to the independent sample t-test. You have to write the mean and standard deviation for each time point. You have to include the t-statistics and degrees of freedom. You have to include the p-value. You have to include the effect size. And here's an example of how that might look. There was a significant difference in participants' weekly alcohol consumption from before and after watching, I shouldn't say watching, should say attending alcohol use counseling. Maybe receiving alcohol use counseling or participating in. Okay, so you see here, this is obviously a study about whether alcohol use counseling could reduce alcohol consumption. You see here that yes, it does based on this test. Before, for one group of people, before the counseling, they have an average alcohol consumption or number of drinks per week of 11.71 with standard deviation 1.97, and afterwards. This value should be switched actually. This mean should say 14.71. Okay, so you see here before the alcohol counseling, they had a mean of, the sample had a mean alcohol intake per week of 14.71 drinks, whereas afterwards they had a mean alcohol intake of 11.71 drinks per week because of the alcohol counseling. So the mean difference is large and significant as indicated by, here's the p-value saying significant, and it's large because we know a Cohen's d value of greater than 0.80 is large. So how do you compute a paired sample t-test? Should say, how do you compute the t-test? Okay, so there are things that the software will do for you, and there are things that you have to do yourself that the software will not do for you. So these are things that software will do for you, Google Functions specifically. It will compute the degrees of freedom, which is just the sample size -1. It will compute the sum of squares for you for the different scores. It'll compute the standard error for the different scores, and it'll compute the t-statistics. What it won't do for you is it won't compute the different scores, and it won't compute the different score variance. So that we have to do manually, which I'll demonstrate in just a moment. All right, and Cohen's d and explained variance, that's not computed by the software as well, so we have to do this by hand. This is the same computation that we did in previous week for independent sample t-test. We had to compute the Cohen's d and explain variance by hand as well. Okay, let's jump into an example problem. So here's the background. A major oil company would like to improve its tarnished image following a large oil spill. its marketing department develops a short television commercial and tests it on a sample of n equals 7 participants. People's attitude about the company are measured with a short questionnaire, both before and after viewing the commercial. Note that participants are being tested twice, once before and once after viewing the commercial. Therefore, we have a repeated measures design. Instructions. Use a peer sample t-test to test whether there is a significant difference between the two time points. For this test, use an alpha level of 0.05 and a two-tailed t-test. Assume that assumptions for paired sample t-test has been met, i.e. the observations within each treatment is independent and the different scores are normally distributed in the population. So that's something to note. I'll add to the slide later. It's about the assumptions. Is that if you want to use the paired sample t-test, you want to make sure that observations within the sample are independent. That just means that everybody provides one. At each time point, everybody provides one score. Like you wouldn't have participant 101 provide depression score twice during the first time point and 2 or 3 times to the second time point. You need that person to provide only one score during the first time point and one score during the second time point. And different scores are normally distributed in the population. So again, this is an assumption. There's a lot of assumptions about variables and about how they need to be normally distributed in the population. That's just given when you run a lot of these tests. So I'll put to myself, include assumptions. Next slide. Okay. So data. Use this data set below for this example problem. The first column is the participant ID number for each participant. The second column is the participants' reported attitudes about the oil company before watching the commercial. And the third column is the participants' reported attitudes after watching the commercial. And you notice here, just like before, I include the exercise sheet and the answer sheet for you to follow along. All right. Next slide. You see, these are the questions associated with the problem. So I'm just going to copy these. Oh, okay, error message. Okay, let's try this again. Okay. Here we go. Now paste. Paste the questions here. Now also make bold all the questions so it's easier for us to read. Okay. The null hypothesis is H naught UT1 minus UT2 equals 0. Remember, this means the mean in the population for time 1 minus time 2 is 0, meaning there's no difference. So how will we state this in words? We would say for the population, there is no difference in attitude between time 1 and time 2. Alternative hypothesis, how you would state it is there is a difference. So it's should say attitude towards the role. Okay, next question. The mean difference between both time points are. Okay. So what you need to do here is to run the t-test, the pair sample t-test. So here are the instructions for that. You go to add-ons and you go to XL minor analysis pack. you don't see this here, that means you don't have it installed yet, and you have to go ahead and go to get add-ons and install this pack. And then you go hit start and scroll down until you see t-test paired to sample for means. That's the same thing as the pair sample t-test. Okay. Right, so look at this data set. So we have the first column is participant ID. So you have each participant on each row here, right? And the second column is the reports about their attitude towards the oil company at time 1. And then the next column is the reports of their attitudes towards the oil company at time 2, after they watch the commercials that's meant to make them feel better or more sympathetic towards the oil company. Okay. So what we do now is we have to fill in this information, and there's only 3 pieces of information we need to fill in to run this test. We need the range of the first time point, the range of the second time point, and where we want to input the table. So this is the range of the first time point, which is just all the scores at the time point 1. We select it on our Excel sheet, a Google sheet, and then we click on here, and then it automatically inputs the reference cells, which is B2 to B8. For the second time point, we again select all the values, click on variable to range, and it says C2 to C8, which means that all these cells are selected from C2 to C8. Then for the output range, we just click basically anywhere on the screen where we want the table to be pasted, and then we click on the output range box, and it just says that the output table will be pasted at cell A10. Then hit OK. And here we go. We have the results of our tests. Remember, we always want everything in 2 decimal points. So I'm going to click this button to make it 2 decimal points. When you answer these questions in Canvas, it's important that you pay attention to the format of the answer, because you have to get the format exactly right in order to get the answer right. That's just how Canvas grades it. It's usually 2 decimal points that you have to enter your results in. Okay, the mean difference between both time points are. All right, so why don't what do we do? We subtract time point 2 from time point 1. What do we get? Time point 2, the mean is 14.71 minus time point 1 is 11.71. What does that give us? Let me just copy this with the equal sign copied as well, and paste it in the adjacent cell. Then Google will do the math for us. So the difference is 3. Okay, the variance for time 1, time 2, and the difference scores are. Okay, so it's asking for the variance for time 1, the variance for time 2, and the variance for different scores. Okay, so I decided to be a nice guy and add a hint on how you could solve this. So here's the hint. Create a new column for the different scores. So time 2 minus time 1, compute the variance for that column. So use the Google function VAR DDD and replace the DDD with the column of different scores. Okay, so here we are creating a new column for different scores. Different scores. We'll say time 2 minus time 1. So we do equal signs. This is time 2 minus time 1. We get, we could have Google fill out the rest of it for us. So this is basically just time 2 minus time 1. So 15 minus 15 is 0. 13 minus 11 is 2. 18 minus 10 is 8. The reason why we do time 2 minus time 1 and not time 1 minus time 2 is we're trying to show a difference between what happened at the later time versus what happened at the earlier time. Because what we're trying to see here is the attitudes, right? We want to know what the attitudes are after watching the commercial versus attitudes before the commercial. Okay, so what's next? So after we create a different column for the different scores, we have to compute the variance for the column. Okay, so the way you compute the variance, so this is the variance of different scores. It says right here, VAR-DDD. Okay, equal signs VAR-DDD. Now you're replacing the DDD with all the different scores here. Enter. You get 12.33. Let's bring this to 2 decimal points. Variance of different score equals 12.33. Man, this also asks for the variance of time 1 and the variance of time 2. So let's go ahead and add those two. Variance of time 1 equals, right here, variance, variable 1 stands for time 1, is 3.90. Variance of time 2 equals, so the variance column, the variance row with variable 2 is the time 2. So the variance is 10.57. The standard deviation for time 1, time 2, and different scores. Okay, the standard and hence standard deviation is computed by taking the square root of the variance. So standard deviation of time 1 is the square root of the variance, and the variance is 3.90. The standard deviation of time 1 is 1.97. Okay. That's the standard deviation of time 2 is 10.57 is the variance. So take the square root of the variance. You get 3.25. Okay, and lastly, what is the standard deviation of the different scores? The variance of different scores is 12.33. So the standard deviation is 3.51. Okay. Let me make this a little larger so we can see better. Okay. Next, the degrees of freedom is. Degrees of freedom is listed in this output table. DF stands for degrees of freedom is 6.00. T statistic says T stat here, so it's negative 2.26. The two-tail p-value is p-value, p one-tail, p two-tail. The two-tail p-value is 0.06. The estimated Cohen's d effect size, and I added a hint here for you as well. Use this formula. Cohen's d equals the mean times 2 mean minus the mean at times 1 over the square root of the different score variance. Okay, let me just copy all this. And put it here. Let's see. D equals. Okay, mean at time 2 is what? 14.71. Mean at time 1 is what? 11.71. This different score variance is what? It's not listed on here. We calculated earlier the variance of different scores, 12.33. Okay, and we want Google to compute this for us. So to copy it with the equal sign in front and paste it in a fresh cell. We get the value is 0.85 is the Cohen's d. The magnitude of Cohen's d effect size is, hint, so I add a hint here, small is from 0.20 to 0.49, medium is 0.50 to 0.79, and large is greater than 0.80. Since this 0.85 is larger than 0.80, then we know that this is a large effect size. Okay. Percentage of variance accounted for. This is another effect size measure. And here's a formula included for us. R squared. Let me just copy this and paste it here. And just replace some of these values. T, delete, put in the T value, which is T stat, negative 2.26. T, delete that again, negative 2.26. Degrees of freedom, delete that. Degrees of freedom 6. Remember, if we want Google to computer for us, you have to copy it, paste in a new cell with the equal sign in the beginning. Google computes it for us. 0.46. Which is the explained variance. Okay. Based on the p-value for this test, we conclude whether is it significant or not significant. And here's another hint. Results are significant when p is less than 0.05 and not significant when p is greater than 0.05. So we can say here, P2 tail is 0.06. So it's not significant. But P equals 0.06 because it's greater than 0.05. So the results are not significant. Same results I got earlier. Yeah, it's the same results. Okay, so we can say how we write this up in APA format is, let me think. Participants' attitude towards the oil company. Would not change significantly from before watching the TV, before watching the commercial. Some information, that's information to after watching. Difference, mean difference in attitude scores across the 2 time points was large and not significant. Remember, for the stats we need to include is the mean and standard deviation. For the first time point, the mean is 11.71. Standard deviation is recalculated by here. Standard deviation is 1.97. Okay. And the mean for the second time point is 14.71. And standard deviation equals 14.71. Deviation equals, we calculate standard deviation here, 3.25. The mean difference in attitude scores across the 2 time points was large and not significant. So at the T value here, T df degrees of freedom equals 6. And T value equals negative 2.26. 2.26. P value is 0.0 equals 0.06, and cohen's d equals, what's the cohen's d value? 0.85. Okay, what's really interesting about this result is that you could have effect size that's large and not significant. So just because you have a large effect doesn't always mean it's significant. It usually does mean it's significant, but there's a lot of other variables involved. Usually if you have a large effect size is not significant, then tends to mean that your sample size was too small, or the standard deviation, or the standard deviation in the group was too large as well, and that could impact your p-value. But there's two independent things: whether your results are significant and how large it is. You can have one and not the other, or you can have both. Okay, that concludes this lecture. Good. Have a good day.